I'm your Komali Mam. In today's session, I'm going to do titration of KMnO4 versus oxalic acid experiment. See, titration, the use of titration is we can find the concentration of unknown solution by using a known solution. Here, our known solution is oxalic acid. I have taken 3.15 grams of oxalic acid and dissolved in this by using, see, first take the weighing machine, put one paper, 3.15 grams you weigh, keep one paper, click on tare, so its weight will be cleared. Then you just weigh 3.15 grams of oxalic acid, take this and put on the paper and you keep this funnel. For time saving I am not showing, keep it here and you add it, then put a distilled water and make up the solution, then shake it. After shaking, make up the solution clearly up to this, here one mark is there, right, H mark, below that H mark you make up the solution, clean the paper also, wash the paper, if you use watch glass, wash it properly, this also in that, into this wash everything, so any salt particles stick also it goes into it. Last drops whatever is there, use a dropper, slowly drop by drop you add it, exactly it should come up to this mark, because it's a primary standard, you should, it is very important, you should prepare exactly, right. So this is what 0.1 molar oxalic acid. I will tell you how to prepare a calculation part at the end. 3.15 grams you take and you dissolve. And what I am going to do in this video is, I am not simply going to do the titration and tell you, I am going to tell you each and every calculation part also. Even I am going to tell you how to prepare KMnO4 also. If you are the student, you only want to do from scratch level, your lab in charge not there, your teacher not there, just reagents are there in the laboratory, you want to prepare everything, then I am going to tell you how to prepare even KMnO4 also. See, KMnO4 I have prepared by taking 1.58 grams of KMnO4 in 250 ml of water. Same way I have taken one measuring flask and I kept this funnel here and weighed 1.58 grams on weighing machine by using a paper and transferred into this. Clearly I mark, shake the solution and I added water up to this H mark. And I have only 2 of this measuring flask, that's why later after measuring I transferred into this, okay, no problem, we can transfer it to, no changes will happen, so I transferred into this. This is for only 1%, so I made for 250 ml. If you are the one you are making for your friends and for your team, then you have to use the bigger value. I'll tell you at the end how to do the calculation part, okay. Now what you have to do is, take this potassium permanganate solution up to the 0 or any other number. I have taken up to 0 and so many practicals I have done, I showed to my students, everything is done. Now I am making this video, so my reading is exactly at 20. This is the anti-parallax card I have made it. I'll upload another video how to make this one, or you, without this also you can see the reading. First, take the pipette, wash thoroughly one pipette. This is a conical flask. Shake your solution. Once your solution is ready, take out your pipette, dip here and drink. No, no. Take 10 ml exactly. See, little bit extra came. Use your forefinger. Slowly you leave it. Right. Done. Then take this oxalic acid into this test tube, into this conical flask. Once you add this into this conical flask, next you take dilute H2SO4, okay. Dilute H2SO4, how to prepare dilute H2SO4 also I will guide you. No need to worry. Every point I will cover in this video. Just from scratch level, you are the one, you want to prepare everything in your laboratory. This test, you only want to do everything, I will tell you. See, this is my test tube. In this, I am going to add one test tube full of dilute H2SO4. This is dilute H2SO4. Usually in the laboratory, when we purchase, we will purchase 98% of sulfuric acid concentrated. We have to dilute it to 2 molar. So how to dilute is, I'll tell you. I'll tell you during calculation, but I'll tell you. Okay. Observe this experiment. So one test tube full. Stir the solution like this. Just swirl it like this. Both will be mixed. Now, this reaction, this is H2SO4 is a medium, acidic medium, okay. And this acidic medium will help us, this oxalate ions, to react with this potassium permanganate ions. KMnO4 gives permanganate ions, both reaction takes place. So, one drop if you put into this one drop both reacts. Oxalate ion reacts with permanganate ion. Oxalate ion reacts with permanganate ion. Once all the 10 ml of oxalate ions reacts with this, the additional drop whatever you are going to put, that will appear as a color, that is called as a end point. So for this experiment we no need to add any external indicator. KMnO4 itself acts as an indicator because its color is, it shows that it's purple color, no, light pink color is our end point. Now we have to heat it. Heat for just warm condition, you heat it. Flame is ready. Keep this conical flask on this burner. Just water bubble has to come, okay. Wait for some time, water bubbles will come. What you do is, meanwhile in your laboratory, thermometer is there, means take the thermometer. Check the temperature using thermometer. It takes around 60 to 70 degrees Celsius comes, means it's enough. Because if that is the condition where this reaction takes place faster. Okay, room temperature this reaction is very slow. If you see in thermometer, it is the mercury level is now at 26, 27 it is there. Room temperature it is showing. If you put into this, it will show the temperature will raise. Now temperature is raising to, see here. See how the temperature is raising. Backside coffee only visible, no? Temperature not visible. Okay. Don't touch this thermometer tip down also more. Just you check and you keep it little top. Because less solution, no, 10 ml means obviously it will touch, okay. So little take care, it may break if more times all students will, if you using, there are chances, so little top. Now you can observe also, conical flask around you can see, na, like water bubbles, atmosphere came. If you are not having thermometer, you can just find it out. If water bubble, you can hold like this and you check. No need to heat up to so hot, like little bit hot is enough. Now the temperature is exactly around 63, 64 like that. So I am going to stop it. Okay, let's do titration. It is exactly at 21. Let me see any drop is here, air bubble is there, anything means I will release it. Okay. One drop little down it was there in reading. Come, I'll show you. Okay, we are beginning here. According to our experiment, I have made the calculation in such a way student has to get by 10 ml reading only it has to come. Okay, now let's begin. Exactly 10 ml only student has to get the reading. First drops add slowly because KMnO4 has to react with this oxalate ion. Okay. Now start. You can add directly 1 ml also you can add. Okay, add 1 ml. You can do faster, no problem. 1 ml, that is a technique. Okay, no need to do drop by drop. Add 1 ml. See how nicely we can do. Add again 1 ml. If you feel, ma'am, no ma'am, I can't add 1 ml, you can add 0.5, no problem. Add 1 ml. Again adding 1 ml. Adding 1 ml. See how nicely reacting. Permanganate ions are reacting with oxalate ions. So permanganate converts into Mn+2 colorless, oxalate ion converts into CO2 colorless gas. So both are reacting. Okay, reacting and forming colorless solution. Fine. See 26 I reached already. See 27 I reached. 28 I reached. 29 I reached. Okay. So here from here 29.4 like that I was there. So what I do is slowly I'll add drop by drop. Okay. Here also first titration you do with the super fast speed. First titration. So that you will come to know the rough value. Then you do second value slowly like this. See. Now I am with next drop only I will get light, already light pink came. By next drop you see how it will change. Already it came light pink. See now. Correct? If you prepare the solutions in such a manner, anyhow you no need to prepare, your lab in charge will give you, but even though I will tell you how to prepare so that if any time if you are not getting support from your team of your college, you only itself you can do it. That's it. Now see the reading now. Come here. Use this anti-parallax card. Check it out. Sharp 30. Okay. Wherever we started 20, exactly 10 ml we got it. Let us. Now what you have done is like this, you got a pink color solution. You are talking to your friends and you have done. So dark pink color came. Then what will happen is I am your invigilate external. You bought this solution to me. You told Komali Mam, see this solution. I got the end point. So how can I check whether your end point is correct or not? The easiest technique is what I do is, or your teacher can do is, take one drop of this, only one drop, okay, one drop of oxalic acid, put in this KMnO4. See? Exactly disappeared, right? So this is perfect titration. Means I got that endpoint with a single drop. For example, again I am going to add one drop. Just one drop. See again pink color ke? So we found the titration exactly. See here little bit I am getting a darker color because the solution is already 2 to 3 days over. If you are doing on the same day of titration, light baby pink color you will be getting. If that in your lab 3-4 days after that, if you do little darker pink, that's it. Based upon its reactivity nature, that's it. Let's begin the calculation part. Now, let us see titration of KMnO4 versus oxalic acid calculation. Okay, once you listen this calculation, you feel very easy. You only will do your lab first when compared to others. Let us see how to do. Here KMnO4 is potassium permanganate. Potassium permanganate dissociates into MnO4 minus. It is called as permanganate ion. This permanganate ion reacts with the oxalic acid. How the oxalic acid will be? In the form of oxalate. Oxalate ion formula is C2O4 minus 2. Now both are reacting in acidic medium. This H2SO4 we are taking. This permanganate ion converts into Mn2 plus. This oxalate ion converts into CO2 and this H plus ions converts into water. This is the ionic reaction. If you observe this permanganate ion, it is pink color which we taken in a burette. This which we taken in a conical flask, these are colorless. Every drop you are keeping this pink color permanganate ion reacts with this colorless oxalate ion and it converts into this manganese ion, CO2 and water, all are colorless. Okay, that is the reason total solution is converting into colorless. But once everything is consumed, this oxalate ion, whatever the permanganate ion extra drop you add, that appear as a pink color. That is our end point. Now here one point I want to tell you. The oxidation state of manganese in KMnO4 minus is plus 7. Here it is plus 2. So it is changing from plus 7 to plus 2. There is a decrease in the oxidation state by 5 units. Plus 7 minus 2. How much? 5 units are decreasing. So change in oxidation state is 5 into number of manganese in this formula. Just a formula you should see. Then how many manganese are there? 1. So 5 into 1 is 5. This is the valency factor of MnO4 minus or KMnO4 is 5. How to find the valency factor, students, tell me? Change in oxidation number into number of atoms is the formula. What atoms you should not see? Stoichiometric coefficient. For example, before 2 is there, 3 is there, that you should not take. In the formula, how many number of atoms are there? That only you should take. Again, you see, in this oxalate ion, oxidation state of carbon is plus 3, here plus 4. Here I am not going to tell how to find oxidation state. I uploaded a video how to find oxidation state. That link I will give in the description. If any one of you don't know, you please watch it. So here plus 3 is converting into plus 4. So change in oxidation state plus 3 to plus 4 means how much is the difference? Higher number minus lower number. 4 minus 3 is change in oxidation state is 1 unit into what is the formula? Number of atoms. How many carbon atoms are present? 2 carbon atoms in the formula. So into 2. So which is equal to 2. So valency factor of oxalate ion is 2. This is important. Okay. So valency factor of oxalate ion is equal to 2. Now we got the valency factors done. Here first one you got some clarity. Starting I told you we have to prepare 0.1 molar oxalic acid. For that I told you weigh 3.15 grams. Let me tell you how I have taken. If anything other than this, if they give in your exam, what you have to do, I will tell you. Okay. So molarity formula is weight by gram molecular weight into 1000 by V is the formula. Okay. So this one you are the one you want to prepare. For example, you only the lab, in your lab only, you only want to prepare everything for your friends or anyone, or you are the student, you only doing this practical, your lab in charge, without their help you are doing. So how much ml you want to make it? Let's say 250 ml. Take that 250 ml. If you want to take 1 liter, take 1000 here. If you want to take 100 ml, take 100 here. Gram molecular weight of oxalic acid is 126. Oxalic acid formula is COOH COH dot 2H2O is the formula. So its molecular weight is 126. Substitute. Molarity, here I have taken 0.1. I will tell you why I have taken 0.1 later. 0.1 I have taken, so into 126, weight divided by 126 into 1000 by 250 is 1s are 4s are. So I will get 4. Then weight is equal to 0.1 into 126 divided by 4. This upon calculation will be getting 3.15 grams. So 3.15 grams we have taken and we dissolved in a 250 ml of volumetric flask. That is the procedure. Okay, this you understand. Ma'am, then you made KMnO4 solution. Now how you prepared KMnO4 solution? See, KMnO4 solution you no need to prepare, lab in charge will prepare. So that calculation also I will tell you at the end. Now in exam part what you have to do? You will write this, you will do this calculation. Then normality is equal to number of equivalents by volume is the formula. So number of equivalents is equal to normality into volume is the formula. So here what I want to say is number of equivalents of oxalic acid is equal to number of equivalents of KMnO4. Why? Because both are reacting. This is in our conical flask, this is in our burette. So you are adding KMnO4 through burette, oxalate ions are reacting. Both the number of equivalents are same. Now what I am going to do is E1 means N1V1, N1V1, which is equal to E2 means N2V2. What is the relation between normality and molarity is normality is equal to valency factor into molarity is the formula. So VF1 M1 V1, N2 means VF2 M2 and V2 substitute as it is. Valency factor for oxalate ion, how much we got? 2. Molarity we prepared for 0.1. Volume which we taken through the pipette. Here I have taken 10 ml. But in your place if they put 20 ml pipette means you should substitute 20 ml. I have taken 10 ml pipette because always we should maximum in a lab time we should give 10 ml only, otherwise students feel difficulty to get the value. So better 10 ml pipette is you have to give. Valency factor for KMnO4 is 5 and molarity students has to calculate, and volume is the one which we got in a burette reading. 10 is the difference. So I started my calculation, my burette reading at 20, finally I got it at 30. So the difference is 10. If you start at a 0, then you will get it at 10. Okay, so whatever the value you are getting substituted, then this 10 cancel, then you will be getting M2 is equal to 0.1 into 2, 0.2 by 5, that is 2 by 50, which is equal to 0.04 units of molarity is capital M. This is the units of, this is the value, molarity, that's it. So in your question, you found the molarity. Then what you have to do is next, you have to find the strength of the solution, okay. What you should do? Strength of the solution. How to find the strength of the KMnO4? What is the titration? We have to find the unknown solution concentration by using a known solution. Our known solution is oxalate ions. Our unknown is KMnO4. So how to find the strength? Strength is equal to molarity into molar mass. Molar mass or molecular weight of molarity we got 0.04 and molar mass of this is 158. So 4 into 158 divided by 100. So 8 4s are 32, 3, 4 5s are 20, 23, 2, 4 1s are 4, 6. So 6.32 gram per liter. what I have done is, this is your answer students, over. Your calculation part, your work is done. Okay. So, what you do is, you will make the tabular column, initial reading, 3 times you will do this experiment, serial number 1, 2, 3. Initial reading how much? You started at 0. You got the reading at 10 ml. This is KMnO4. Initial reading, final. You write here. Initial reading in a burette. Final reading in the burette. So, initial, final, the difference. So, how much is the difference? That is the volume of KMnO4. This is V2. This is V2. Okay. Final minus initial. 10 minus 0 is 10. Again, you started at a 10. For example, you got it 20. So, 20 minus 10 is difference 10. Again, you started at 20, you got it 30 exactly, then 10. Like this, you should make the table. At wherever I started at 20, so I should put 20 like that. Wherever you started, fine. Here some additional points, tips I want to tell you. That is, dilute H2SO for preparation is most important. Okay. If you did not prepare dilute H2SO4 properly, your solution, whatever you are doing titration, that will be converted into brown color, or like some kind of chocolate, some kind of brown color, it will change. So, it is important for the preparation of H2SO4. Concentrated H2SO4 bottle will be there. Take that concentrated H2SO4 bottle. From that concentrated H2SO4 bottle, take for 1 liter means take 111 ml. So, take 111 ml, take 1 liter big beaker, take water 111 ml water, you put this 1 liter distilled water, 111 ml of concentrated H2SO4. No ma'am, I am the student, I want very less amount only for me, not my friends or not for the lab. Then what you have to do is, just 50 ml if you prepare, it is enough. Take a one small beaker of 100 ml or 250 ml, better 250 ml, okay, acid, no. So, take distilled water 50 ml. In that 50 ml of distilled water, you just add 5.5 ml. Okay, for 1000 ml means 111. For 50 ml means how much? Do that. 1000 ml, 111 ml. Then 50 ml means how much? Do the cross multiplication. 50 into 101 divided by 1000. Like this, any calculation for how much ml you want. For 1000 na, 50 na, 100 na, anything you can do it. Here I will be getting 5.5 ml. We should add in the 50 ml. So, our dilute H2SO4 is ready. Like that I prepared. And another point I want to tell you all, that is how I prepared KMnO4 solution. Here I have prepared by taking 1.58 grams of KMnO4 I have taken, and I dissolved in 250 ml of water. Like how I have taken conical volumetric flask 250 ml. I kept this funnel, and I weighed this by using just paper I used. I got exact reading. You no need to take a watch glass or measuring bottle, weighing bottle, not required. Simply take paper, good quality paper you take, which is like any plastic cover type of paper you take. Then again you should wash the paper also here put that paper, wash after putting into this, wash the paper also, wash this funnel also. Just add little amount of water only. Once you put this 1.58 gram, add little water, shake thoroughly, and mark will be here. Don't add up to here. Up to here add water. The last few, shake well, last few drops you add by using the dropper slowly, and just make the solution, continuously shake the solution. Your KMnO4 is ready. Take the burette and wash thoroughly with the water, rinse thoroughly with the water, no air bubble should be there. You just add this KMnO4, rinse with KMnO4, leave the stopcock, entire solution should run. After that you fill it up to the 0 mark. For colored solution, we can't see lower meniscus clearly. So this higher point meniscus only we have to take as a reading. So 0 you take it. And this KMnO4, mostly you no need to prepare. This is only you are going to find it. Okay, I am just giving you the information. If you are the one you want to do this in your lab with every ingredient, starting onwards, scratch level if you want to do, I have given the complete information. And another point I tell you, ma'am, why you have taken only 1.58 grams, why you have taken only 0.1 molar oxalic acid means, the reason for taking is, if we take these calculations what I have taken, student will get exact value at a 10 ml. It is important. If we don't take these values, higher value if they get, it is little bit difficult for them. And still about this titration, if you want more information, that link also I'll put in this description of this video. Go through that for more updates, but mostly this information is sufficient. I hope you like this video. If you want to get more practicals, more tricks and tips, just subscribe to Komali Mam channel. It is like one encouragement to do more videos for you. Please hit on like. Thank you so much for watching this video. See you again in next video with more lots and lots of tricks. Thank you all.